We will now get some practice in finding probabilities in a uniform distribution. A random subway waiting time can be any fraction of a minute between 0 and 5 minutes with a uniform distribution. State the random variable and draw a picture of its distribution. Let's start with the random variable. So the way we can write this out is typing RV for random variable x, and we can just say random variable x. Now you can name it any other variable besides x if you wanted to. I'm just going to keep it consistent with x. And the random variable is a random subway waiting time. That is what our random variable is. You can see it's right here as well. Okay, let's draw a picture of its distribution. We know it's uniform, so it's straight across. We're going from 0 to 5 minutes. And on the vertical, that's your probability. So what's our height? Remember, this rectangle has to equal 1. If you recall from the last video, you do 1 over, then 5 minus 0. So 1 over 5. Or if you take 1 divided by 5 on your calculator, you get 0.2. I think decimals are slightly easier to use, so let's use 0.2. To check yourself that you did this correctly, you can take the length times the height, 5 times 0.2, and you better get 1, else you did something wrong. So that's a good check. Okay, now we can move on to B. Find the probability that you have to wait less than 1.5 minutes. So this is very important to get used to this notation. We're going to always start with, we're looking for probabilities, so start with a capital P. Our random variable is x. We're going to write less than 1.5. Okay, so let's look at our graph over here. We can label these as 1, 2, 3, 4, and 5. So 1.5 is here, kind of like our number line in the review at the beginning of this section. 1.5 is here, and everything to the left is less than. So this distance, you can take 1.5 minus 0, or you can just notice that it's a length of 1.5 times the height, so 0.2. Remember, this is base times height. When you multiply that, you get 0.3. Okay, let's go to C. Find the probability that you have to wait between 1.5 and 4 minutes. So x is going to be greater than, read it from right to left, x is greater than 1.5 but less than 4 minutes. So what you can do here is you need to find the length of the base. So you have 4 to 1.5. So what's this length? So you just take 4 minus 1.5. That's your base, and your height is 0.2. So 4 minus 1.5 is 2.5. Copy over the 0.2, multiply that. You get 0.5. Okay, the next one, we are looking at the probability that you have to wait greater than 4 minutes. So here's 4 minutes and everything greater than that. So probability x is greater than or equal to 4. Again, the equal to doesn't really matter. It's not going to have any effect on this. What's the distance or the base? You can do 5 minus the 4 to get 1. I'll write it out here for you. Times your height. So we have 1 times 0.2. So we have 0.2. And then find the probability of exactly 2 minutes. So probability that x is equal to 2. Again, because this is continuous, it's 0. This kind of makes sense if you think about the properties of continuous, of just the word continuous. It continues forever and ever. So you can never have exactly 2 minutes. You could say 2.0000, lots of zeros and then a 1, or just lots of zeros. But you could also think of it, because we're talking about area, a single line does not have any area. So you can think of that way as well. A computer generates random numbers between 0 and 1. What is the probability of the random number being between 0.62 and 0.98? So what I would do is draw your uniform. 0 and 1. We're going to assume that these are all equally likely to occur, so then that's why it will be normally distributed. This is your random number down here, and then vertically is your probability. So the height is going to be 1. 1 times 1 is 1. All right, we want the probability that x is between 0.62 and 0.98. Just like before, we need to find the distance between these two. So you're going to subtract, so the highest value minus the lowest. That will give you your distance on the base here, times it by your height. So you get 0.36 times 1, which is 0.36. Assume that waiting times for the Metro Gold Line are uniformly distributed between 3 and 8 minutes. What is the probability that a random waiting time will be between 4 and 6 minutes? So let's first start with our graph. So 3 to 8 minutes. The distance between these is 5. Or if you want to do the formula 1 over 8 minus 3, so that's 1 over 5, or 0.2 is going to be our height. So 0.2 times the range of our base of 5 will give you 1. So that's the correct height. Let's state what the random variable x is here. This is the random waiting time for the Metro Gold Line. Okay, we are looking for the probability that x is going to be greater than 4 minutes and less than 6. So here's 4, here's 6. So we're looking for that probability. So take 6 minus 4 to get your base and multiply it by your height. 6 minus 4 is 2. Times it by your height, you get 0.4. And what is the probability that random waiting time will be greater than 5 minutes? So x is greater than 5. Let's look at the graph and shade. So find 5. And everything to the right. So we have 8 minus 5, Or you could have figured out that it was a distance of 3 times it by your height. So 3 times 0.2 equals 0.6. And just as a side note, for A, the random variable x was just a random number.